let's finally look at part D. This is also an alternating series. Let's see if the ratio test is going to work. Okay, let's try it out. All right, so I just grabbed an together with, in fact, the alternating part. So I'm going to look at the ratio an plus 1 over an, keeping the absolute value in. So this is minus 1 to the n plus 1, 2 to the n replaced by n plus 1. So it's 4n plus 4, okay? And in the bottom you have n replaced by n plus 1. That makes it 2n plus 3 factorial. And as I said, this is going to be all divided by an. But I want to flip this over to save space, because that's also another fraction, right? 2n plus 1 factorial and minus 1 to the n, 2 to the 4n. Okay? So I'm going to split this exponential term, and I'm going to rewrite this factorial in terms of this factorial 2n plus 1, right? And let's see how this works. So minus 1, by the way, minus 1 to the n plus 1 is minus 1 to the n times minus 1. I mean, again, as I said, this is alternating care. It doesn't matter because we're taking the absolute value at the end. We can disregard that at this moment, but anyway, so just showing you the full steps. So 2 to the 4n times 2 to the 4. 2 to the 4 is how you expand this term out, okay? And this is 2n plus 3, 2n plus 2 times 2n plus 1 all the way to 1, but that number is in fact 2n plus 1 factorial, okay? And this is 2n plus 1 factorial and minus 1 to the n, 2 to the 4n, okay? So let's look at the cancellations now. 2 to the 4n, 2 to the 4n, 2n plus 1 factorial, 2n plus 1 factorial, minus 1 to the n, minus 1 to the n, and we take the absolute value. This minus 1, again, will not matter because absolute value is going to sort of like absorb that term, okay? So then what I'm left with is 2 to the 4th, 2n plus 3, 2n plus 2. 2 to the 4 is 16, so I can just write it out. Okay, so let's pass the limit. So let me just put a comma here. Let me continue from here. Limit of an plus 1 over an. This is sort of like a relatively easier limit because the top is just a constant. The bottom is just n-related terms. As n approaches infinity, the bottom goes to infinity. So this limit is 0, which is less than 1. Good news, because when the limit is less than 1, then the series converges absolutely. Okay, so you go back and then conclude that this series converges absolutely. Okay. Check the exercises, and then you can also find, we had one case where the test was inconclusive, but we don't have any exercise right now to prove the divergence, but I'm sure there's a lot of them in the exercises, and again, when the limit is strictly greater than 1 or infinity, so that's when you conclude that the infinite series diverges. All right, that's all for the video for now. Thanks for watching. I'll see you in another video. Bye.